Hello guys, in this class, we're going to kickstart a new series of classes on magnetism. So I'm going to take my time. It's going to be a long series. Are you seeing that? We'll take our time. We'll treat magnetism from the beginning to the end. And we're going to finish everything. And we'll take the past question, be it Waec, be it Jamb, be it Neco, and so on and so forth. Let's go there. Let's start from the word from the beginning. Now, the question is, what is magnetism? Of course, this will be our lesson one. We're going to talk about the introduction to magnetism, what is a magnet, we'll talk about the history of magnetism, and so on and so forth. Well, I'll start by telling you that a magnet...
Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb and Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons, you have access to your notes, you have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy.
is simply anything that attracts object to itself. Anything that attracts an object to itself said we call what? A magnet. A magnet. Now, that object can be metal. So anything that attracts object to itself. Now, should I say as a boy, you are, or as a girl, you are attracting a boy, you are a magnet? Well, but yeah, that's not really the definition of magnet. I'm just kidding. But a magnet is anything that attracts object to itself. So let's see that definition was a magnet. Everybody, a magnet is anything, look at it, a magnet is anything that attracts objects to itself. Now these objects are metals, okay? Anything that attracts object that's metals to itself is simply called what? A magnet. Everybody wants a magnet. A magnet is anything that attracts object to itself. So if you know you attract people to yourself, you're a magnet. Do you understand? Now, let me give you a mental picture of a magnet and this magnet attracting iron filings or small nails. Look at it. You can see that this is an horseshoe magnet. You can see that this magnet is attracting what? Nails. So everybody want to go, what's a magnet? A magnet is anything that attracts object to itself. For the last time, a magnet is anything that attracts object to itself. Now, if you understand what a magnet is, now quickly let's now talk about the history of magnets. Now, before I explain further, I would like you to know that there are different stories about magnets. But among all of them, the most standing is this I'm going to explain to you. This is a man called Magnus. He's a shepherd. So Magnus is from a country called Greece. And he lives in a city called Manganese. So Manganese or Magnesia. So there's a man, this man is a shepherd called Manganese. He lives in a city called Magnesia, and that city is in what? Is in Greece. It was said that this man, who is a shepherd, one day went to cater for his flock, and he was holding a metal rod, and he observed that the base of the metal rod was attracted to a block, as well as the nails in his shoe was attracted to that block. This block you can see is that block I was saying, which is a magnet. He didn't know it was a magnet. So he was the first one that was shocked that why would this thing attract my shoe and the base of my metal rod? Are you seeing that? Now, because this man's name was Magnus and he was from a city called Magnesia, they now call this, the first time it was called, they now call it magnetite. Magnetite, that's Fe2O3. Fe2O3, magnetite. Are you seeing that? So it was now called what? Magnetites. Are you seeing that? So everybody, we said that there was a man called Manganese in a city in Magnesia in a country called what? Greece. This man went to fence for his sheep and saw that the base of his rod and the nail of his shoe was attracted to a metal block. And because this man was from Manganese and he was in Magnesia and he was in Greece, they now call it what? Magnet, and that's Fe2O3. Now let's see that. We said that, take note that according to Greek legends, magnetism was first discovered by a shepherd named Manganese who lived in Magnesia in what? In Greece. His name was Magnus. He lived in Magnesia in what? In Greece. How did he discover that? Manganese was herding his sheep through the mountains. Suddenly he noticed the iron of his stick and the nails of his shoes were attracted to a magnetic rock. I just explained that to you, that the base of his rod and the nails of his shoe were attracted to a magnetic rock. Therefore, the stone was now named magnetite, after the name of the word of the shepherd or the country was what he was found. We said that his name was manganese. He was from a city called Magnesia in Greece, so they now name it what magnetite. And they didn't know much about it, but people now started using it to get direction, just like compass. Are you seeing that? Because it comes to line the north-south direction. We're going to talk about that. So it helps them as it gives them direction. And because it gives them direction, all the days people now started calling it leading stone. Hence the name lodestone, meaning what? Leading what direction. And look at it. The stones were used by ancient navigators as compasses in directing their movement. Due to this, it was now known as what? Lodestone, meaning leading what? Stone. Actually, there are different stories. Are you seeing that? But some will say they call it lodestone because it helped to attract magnetic materials. But some said that the reason why they were calling it lodestone because it gives them what? Direction. So this is just the simple story of what magnetism. I say that again. A man known as Manganese in a city known as Magnesia in Greece, right, was trying to fend for a sheep. He observed that his rod and shoe was attracted him to a block, which they now call what? Magnetite. And because it was used for direction, now call it what? Lodestone, meaning what? Leading stone. Please, do you understand the short history of what? Of magnetism. Now, if you say you understand that, let's not talk about magnetic pole.
Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb and Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons, you have access to your notes, you have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app, where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy.
I'll start by telling you that magnets are polar. The word polar means they have two ends. Just the way we have, when we say you are polar, it means you have two ends, either the positive end or the negative end. Are you seeing that? So magnets are polar, or we call them what? Dipole. Dipole means they have two poles, which is the north pole and the what? South pole. Now, please understand it very well. Just like electric field too, we have the positive pole and the negative. Magnet too is dipole. It has two poles. This is a constant past question. Magnetic pole, what are the magnetic field or magnetic? What are they? They are dipole. Or you say they are polar. They have the what? The north pole and the what? And the south pole. Now, let's take note that magnetic field, they are more strongest at the what? At the pole and weakest at the center. That's the same thing for electric field. Electric field are stronger at the pole, weakest at the center. Even your gravitational field, are you seeing? They are stronger at the pole and weaker at the what? At the equator. The equator is the center. Do you understand? So magnetic field are stronger at the pole and weakest at the what? At the center. Now let's get a magnet. Look at it. This is a magnet. You can see that every magnet has two poles, north pole and what? Our south pole. That's why we say that magnetic pole are dipole. Everybody, why magnetic field dipole? They are dipole because they have two poles, which is the north pole and the what? South pole. Where are the strongest? They are strongest at the pole and the weakest at the pole. Now let's check past question. If you fail this past question, I'm going to blow you. The past question is Jamb 2005 question 20. The question says the north pole of a magnet can never be separated from the south pole because of which property? Option A, say that magnetic dipole. B, said magnetic octopole. C, said magnetic monopole. D, said magnetic quadrupole. One stupid idiot boy in the exam will go and say magnetic octopole or magnetic monopole. We said that magnet are dipole. Just where electric field are dipole, magnetic field are what? Dipole. That means they have both north and south, making option A to become the what? The answer. Do you understand? Let's answer that past question. This is a Waec past question, Waec 1999, question 33. The part of a bar magnet at which the magnetic effect is strongest is called the part of a bar magnet at which the magnetic effect is strongest. Option A is called the poles. B said neutral point. C said magnetic declination. C said magnetic meridian. Everybody, where is the strength of a magnetic pole highest? It is highest at the what? At the poles and weakest at the center, making option A to become the what? The answer. Now take note that we say magnetic field are what? A dipole. It means that a magnetic field cannot be isolated. What do I mean? If this is a magnet, this is a magnet, and this is north and this is south. If you cut it into two, you are going to have another magnet of north-south, north-south. You can see that even if you cut this one, you're going to have a small magnet that is north-south, another small magnet that is north-south. Even if you cut, you're going to have north-south. That means you can never have an isolated magnetic field. Please take note about that. Are you seeing that? Look at the diagram I gave you. This is a north-south magnet. We cut it into two, we have north-south. If you cut it into two, you are still going to have north-south. If you cut this into two, you are still going to have north-south. Cut this into two, you are still going to have north-south. Cut it into two, you are still going to have north-south. That means you can never have an isolated magnetic. You cannot just have only north, or you cannot just have only what? South. Do you understand that? I make that to you. Magnetic pole, look at it, everybody. A bar magnet broken into two or more pieces. Each of them will have a north pole and a what? South pole. Hence, what is the hence? It is impossible to have a magnet with only one magnetic pole. If they ask you in the exam, you can never have a magnet with one magnetic pole. Or we can say that a magnetic pole cannot be isolated. A magnet pole cannot be what? Isolated. But that is one difference between magnetic and electric field. In electric field, you can have just a positive charge. Of course, we talk about electric potential, work done momentum in a positive direction, right? The positive charge. Are you seeing that? So you can have one isolated positive charge. You can have an isolated negative charge. But in magnetism, you can never have an isolated magnetic north or magnetic or south. That's one difference between magnetic field and electric field. Now, let me give you a mental picture of that. Difference between magnetic field and electric field. We said that this is an isolated positive charge. You can see it's on its own. This is an isolated negative charge on its own. But for magnet, it is not so. Are you seeing this? A magnet will cut it into two. We have north and south. We have north and south. You can never have an isolated magnetic field. Even if you cut these two, you're going to have north and south. Cut these two, you're still going to have north and south. Are you seeing that? So you can never have an isolated north pole. But in electric field, you can have an isolated positive charge and an isolated negative. That's one difference between magnetic field and electric field. Do you understand that? Now, when a magnet is suspended, that magnet comes to rest in the north-south direction. When a magnet cannot just lie horizontal, it's going to lie like this. This side is called the north side, it's called the south. That is why we said it is used for what? It is used for direction. Compass, as old days, that's why they call it lodestone, as leading word stone. Anytime a magnet is sustained, it come to rest in the word north-south direction. Please take me as a constant or past question. Anytime a magnet is suspended, it comes to rest in the north-south direction. Anytime a magnet is suspended, it comes to rest. Look at it. This is the north-south. You can see it does not lie horizontal. It comes to lie in the north-south direction. That's what we call the principle of compass. Everybody, what is the principle of compass? That a magnet will come to rest in the north-southward direction. Do you understand that? Now, let's now talk about what's the molecular theory of magnetism. Because we know that magnet help to attract other materials. Where does this thing come from?
So when it comes to creating an account, right? This is the interface of the app that you can see. You can see create account and you can also see login. Now, what you do is this: as a new user, you don't have an account yet, so you don't need to go and log in. You go and create an account as a new user. Click on that create account button. Once you click on it, the next thing is put your phone number. Place in your phone number. You can see +234. Then put your phone number, whatever your phone number is. If you don't have phone, you can use your mommy's phone number and put it there, right? Or your daddy's phone number. Use it, and then you can proceed and create the account. So let's go. So once you create the account, you are putting your phone number. What happened? Put your name, your correct phone number, please. Put your name. If your name is John, what do you fill in there? John. And then your last name, Frank. Fill in John Frank. And what's your email address? Okay, if your email address is johnfrank3@gmail.com, you fill it there. And then your password, very important. You create your own password, 6 digits. You can use your phone number, the first 6 digits of your phone number, or the last 6 digits of your phone number. Or you can, okay, since your name is John Frank, you can say, okay, my password name is John, right? John 123. And then you go and repeat the same thing, confirm password. What will you type there? Your John what? 123. You can decide to view it to yes or and then see whether you are doing the same thing, whether what you are doing is correct, right? All you have to do is just click the I button there and then you view it. And then come to select education. You are preparing for Jamb or WAEC. In select education, there are 4 plans there. University, that's for people that are in university, probably 100 level, 200 level, right? Yes, their classes are also there. Secondary, for those in secondary school, primary. But for Jamb and Waec, Baba, click WAEC, Jamb Pursue Utme, right? As the select education, select level. You are not preparing for Pursue Utme, you are preparing for Jamb and Waec, right? Okay, click on the what Jamb and what Waec, and then create your account. 2 seconds. Pass, you don't enter, it will load, and then it will open for you, and it will tell you, welcome John, right? Your classes are now what? Ready. What do? Start learning.
Let's trace it. Now, what is the molecular theory of magnetism? Now, I'll start by telling you that first, atoms behave like magnets. Now, let's go to physics. Let's trace everything back to physics now. Atom behave like magnet. What's an atom? An atom consists of the nucleus and the revolving electron. Now, because there is an electron and there is a nucleus, inside the nucleus is your neutron and your proton. Are you seeing that? So, because the electron is revolving around, while the nucleus is spinning around. Look at the nucleus does not move, so the nucleus spin, while the electron revolve. Now, because this revolving electron and the spinning nucleus, there is a magnetic field. Why? Because between the nucleus and the electron is a force known as electrostatic force. So electrostatic force is inducing a magnetic field. So atoms behave because of the atomic structure. Even humans, the human body behaves as magnets. The aspect of medicine called that's radiography. Eye of medicine, radiology, where you go for, many of you have gone for scan. There's a type of scan called MRI, where they will ask you before you enter an MRI scan, they'll tell you there any metal in your body, because that metal will pick you. Because MRI works with the principle of what? Magnetism. That's why MRI means magnetic resonance imaging. Because the human body behaves as magnet. In as far the human body consists of atomic structure, so the cause of magnetism is atomic or atomic or structure. First of all, you know that atoms form what? Molecules. So we said either you are hearing them say atomic structure, molecular or structure. Do you understand? Let's explain that. Take note that the molecular theory of magnet explain how materials become magnetic by focusing on the behavior of tiny particles called what? Atoms or what? Molecules. So when we focus on tiny molecules of that material, in as far you are attracting a substance, in as far you magnets can attract you, we now try to check you, or we try to check the magnetism. What is it in this matter that this magnet is attracting? So we observe that because of their molecular and their atomic and molecules, we now start to say, okay, there's something about this molecule. What are the things we are checking these molecules? Now take note, they include number one. What the first one? Take note that atoms are like tiny magnets. I just explained that. Each atoms act like a tiny magnet. Why? Because of the movement of what? Electrons around the nucleus and the spinning of the world of the nucleus. Look at two things. The reason why we say that atoms that is being attracted by magnets has that magnetic property is because number one of the revolving what? Electron. The electron is moving around the nucleus, so we call it revolving what? Electron. And number two, the spinning nucleus. The nucleus doesn't move; it just spins. Are you seeing now? Because of this revolving electron and the spinning nucleus, this makes us to say that okay, this structure behaves like a what? Magnet. So we say that atoms are like tiny magnets. Each atoms act like a tiny magnet because the movement of electrons around the nucleus and the spinning of the what? Of the nucleus. This motion creates a what? A magnetic field. Now look at this diagram, guys. This is the electron. The electron is what? Is revolving around. And this is the nucleus, right? This nucleus, you can see, is spinning around the what? It's just spinning. It's not, it's just spinning. Spinning is different from revolving. Revolving is you are revolving. Spinning is that you are just in one place, turning. Revolving means you are going around. Spinning, you are just turning. Are you seeing that? So because of the revolving electron and the spinning nucleus, it induces a what? In magnetic field. This motion of the electron and the nucleus induces a what? An electric field. Do you understand? Now, I'll still explain that again. Everybody, all eyes on this diagram. You can see that this is we said that this is the electron, right? The negative, while this is the nucleus, right? As the electron is the revolving electron and the spinning nucleus. The motion of both of them causes a field, which is called magnetic field. Now, what is the second thing? We said there are two things that talk about the molecular theory of magnet. Number one, we said the atomic structure. Now we have known that the atomic structure in this is what a magnetic field. Now let's now go further. If we already know that they have atomic structure that induces a field. Now if we now bring a magnet close to that metal, what will happen? That's what number two. Number two is that we talk about the alignment. Alignment creates what? Magnetism. Just calm down, you understand. And now we explain that number one, that because there's electron, a revolving electron, and a nucleus, there's an induced magnetic field. Now, but all atoms, all elements have atomic structure. Sulfur has atomic structure. Are you seeing that? Carbon too has atomic structure. So, as sodium has atomic structure. Now, but can all of them attractive? Like sulfur is not a metal, so it does not attract. So, but it has atomic structure. What is it? Despite having atomic structure, what is it that you possess that make you to be attractive? Now, number one is having atomic structure. Number two, now, this atomic structure must tend to align. So that is what we call alignment creates magnetism. In most materials, the tiny atomic magnet points in random direction, cancelling each other. That means the electrons and the positive charge are pointing in different directions. That means they will cancel each other. Such materials are non-magnetic. But in magnetic materials like iron, they have atomic structures which align in the same direction, reinforcing each other. This alignment is what causes magnetism. I'm going to show you. So this alignment creates a strong magnetic field. Now, for you to understand this, let me give you a mental picture.
Now that you have created your account, right? For you to start learning, what do? Okay, you can see that your use of English is there, mathematics is there, biology is there, physics is there, chemistry is there. Your classes are organized, they're all there for you, right? What do? Okay, I want to start learning biology. So click on the biology, immediately you click on it, living organisms, that's chapter 1, right? Oh yes, that's strictly to your JAMB syllabus. And what happened? Let's say, for example, you want to watch your class on cell and probably cell structure, right? What happens is that you click on it. Immediately you click on it, you see all the classes will display. History of cell, types of cells, cell organelles, and all of that. Okay, sir, I want to watch history of cells. You click on the history of cells immediately. Hello, friends. Your class will start playing for you. It will start playing for you easy and direct. And what happened? You can even choose to make it full screen. Right? Make it full screen. What happens? You are started learning and you are enjoying your classes. In fact, you may choose to say, okay, I want to download my classes. In fact, you can fast forward, you can take it backwards, you can pause, you can rewind, anyone you want to do. You can even say, oh, sir, I want to download my classes, right? Probably you use Nightsub just to click on download buttons. When you click on download button, you see the download. Before you know what will happen, the download will start loading. As it start loading, you can see it is moving. And then it's enter your phone. Are you getting it now? You can now go and start watching your downloaded classes. You can download as many classes as possible as you want to download. Now, you can even choose to say, okay, sir, that's the notes underneath it. It's the same thing for everything. I want to download my notes. All you have to do is click on the download for your notes. Before you know what is happening, it has entered your phone. You may choose to come to the notes, right? Under the characteristics of living things, let me open the notes and read the notes and go through the past questions. So you see, well organized and structured notes, direct to the points, focusing on your syllabus for you. There are past questions for you in abundance. You see, you have your past questions here. You can choose to say, okay, I want to zoom it in, right? And then the same thing for all subjects, and you are following. The answers are there. Number one answer is B. Why is the answer B? It is explained for you in details, every singular thing, and then you are following your classes. You are done with that. You come to the next, you see your notes, everything structured and organized to the core. In fact, at the end of the day, there is a blow piece for you. You have done well. Get out, you too much. Everything is structured and organized for you in the app, right? And you can now choose to say, okay, sir, What about chemistry classes or physics classes? You can do same. Use of English, all of them, they are there. When you click on your chemistry classes, what happens? Separation of mixtures and purification. All of them are in line with your JAMB syllabus. Chemical combination, right? It just goes straight. You see, chapter 1 alone has 39 videos. 39. You sit yourself down and you start learning, and you are following all of them one after the what other. Does it make sense? Are you with me? When you want to access your download classes, all you have to do is just scroll down right on your home interface, go to your access your download classes. Start now. You start, you see them, right? In fact, you may even choose to go and practice CBT, right, or past question. Let's say, for example, I go to my CBT, the one that has to do with my my biology. Then I want to take all the questions on that cell, probably your WAEC cell or the JAMB question on it, right? Just to click on it. So you see, all the questions are there. There are 40 questions there for you already. All of them on that cell. What happened? Which of the following cell inclusion can destroy other cell organelles? Probably you now say, oh, Sam, answer is lysosomal. You choose it, you go to next like that. At the end of the day, you see your answer, see your corrections. All of these things are in the LearnLift app directly for you. Are you with me? So as far as your JAMB 2025 is concerned, my dear, you don't have an excuse whatsoever to have anything less than 300. Are you with me? All your classes are available for you. All you have to do, start learning now.
Download the LearnLift app now.
Now let's explain the diagram now. Look at this diagram. We said that spinning moment of nucleus and revolving what electron. Now let's explain. Give me two diagrams. Look at this guy. Let's call this the nucleus. Let's call this the electron. This arrow you see is called moment. So spinning nucleus, as a nucleus is spinning, it causes a moment. So that's how we say spinning moment of nucleus and revolving what electron. As far as there is movement, it is called moments. Are you seeing that? So as a nucleus is spinning around, it induces this arrow talk about what the moment. So the spinning moment of nucleus, we can also call the revolving moment of electron. This is the electron, this is the nucleus. So it now depends, are they going to align to magnetic field or they are not going to align to magnetic field? The first property we'll talk about that causes magnetism is that they have atomic structure, and we'll say all elements have atomic structure. Number two, now we'll now talk about the alignment. I've shown you this is how they look like. Now let's not talk about the alignment. Look at it. What is now the cause of magnetism? The cause of magnetism is due to the spinning moment of revolving electron and spinning what nucleus. The spinning moment of revolving electron and revolving what nucleus. Now let me give you a mental picture. Now look at this diagram. First, let's look at the diagram. First, there's no magnetic field here. Why? Because there's the revolving electron and the spinning nucleus are facing different direction. This one is different direction, this is different direction, this is different direction, this is different direction. Because they are facing different direction, they are canceling each other. We'll talk about the alignment. If you go back, I talk about alignment. Now, when they align to magnetic field, that material is said to be what? Magnetic. Now, let me give you another diagram that is magnetic. Look at this diagram. This is a magnetic field. B is known as magnetic field. What can you see? All of them are aligned towards the magnetic field. This is a magnetic material. This is non-magnetic material. This is what happened in their default stage. So, look at it. What causes magnetism? I start by saying that all elements has atomic structure. This atomic structure has a moment, but all of them are in what? In random direction. So if we bring an electric field, which is this big B, when that means we bring an electric, what we say an electric field mean? It means we bring a magnet. If you bring a magnet, if all the elements, all this, their atomic structure tend to align with this structure, it is said to become magnetic. But if you bring a magnet and their structure still remain like this, that material is said to be what? Non-magnetic. So what causes magnetism? Magnetism is caused by the alignment of spinning or revolving electrons and nucleus. When the electrons and the nucleus align with the magnetic field, that material is said to be called magnetic material. That's the cause of magnetism. Everybody, what's the cause of magnetism? The cause of magnetism in the magnet is due to the spinning moment of revolving electrons and the spinning moment of nucleus. Do you understand? I say that again. Every atomic structure have electrons and nucleus. The electrons are revolving, the nucleus are spinning. But on a default stage, all of them are in opposite direction. They are in different direction, like what you can see here. So because they are different direction, no magnetic field. So this is what can happen like this, like sulfur. But if you now bring a magnet close to it, if all of them align to that magnet, that material, this can be, let's say, can be cobalt. Are you seeing? Because cobalt is a strong magnetic material. It can be steel. This can be iron. So if you bring it close to magnetic and all the atomic structure align, that material is said to be what magnet. So that's what I say. The cause of magnetism is due to the spinning movement and revolving electrons of that nucleus. Do you understand? We're going to talk about the past question. This is just like an introduction.
Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.